Okay, lesson 2-3. Before we get going, I know a lot of people with athletics have been asking stuff about grades. So I'm going to tell you about a couple things. Even though we're working on lesson 2-3, which right here, you'll see everything you need. Let me get to your class, even though they're the same. I want you to know I did open up the test. Some students have been asking, can I retake? Can I do things like that? I have opened it up, and there is now a second attempt available. So if you want to retake it, as you try to do your late work or whatever, get your grades up, it is now open to retake. I reserve the right to change you down to a 70. I'm not saying if you make a 75, I'm going to necessarily take the 5 points away. No promises. But if I look and someone takes in the very last minute and makes 100, and I think there might be something fishy, I reserve the right, because you're late, to change it to a 70. Does that make sense? Okay. So I do reserve that right just to be fair to other students, but it's available to all students to take a second attempt. So if you think you can increase your grade, go for it. That's located in Chapter 1. So if you go to the Chapter 1 folder, down here you'll see the Chapter 1 exam. You can click down there to take it. All right, so that's Chapter 1. Today we are in Chapter 2, Lesson 3. We are working on 2-3. So make sure you're not falling behind. Last week we did 2-1 and 2-2. And as we go through the Zoom each class period, I'm going to go over there's 4 things required. We will go through the first 3. The attendance link is on the board. The YouTube lesson playlist is the same thing I teach through in the Zoom. And so during class, we're going to see bell ringers, guided practices, and ACP questions. So you should have those 3 things done if you attend in person or if you attend live on Zoom. You should have those 3 done at the end of each lesson cycle. All that leaves you to do is your homework, other than Alex is what I'll call homework. So just make sure you're aware of that. We are on lesson 2-3. Let's not fall behind. Chapter 2 has 6 lessons. Don't be pushing things off, because in 3 lessons we'll have a test. You don't want to be that far behind. Does that make sense? With that, let's get going. I got Desmos open because I will use that today. Let's start with our bell ringer here. There are 3 problems. Let's start with number 1. Number 1 says, try to graph f of x without a calculator. So we'll check our answer with Desmos, but we're going to start, like it says, without a calculator. Last class, we talked about a few different things. We combined, really it's the last 2 classes, we combined some information together. And so the first thing I want you to know that we combined is, if you are in factored form like this is called factored form, whenever you have parentheses multiplying. Factored form can find you zeros. I'm going to write it up here. Factored form finds 0, meaning where it crosses the x-axis, it finds zeros, as well as multiplicity. So I'll say zeros and multiplicity. Now, what do I mean? We can learn a few things about this graph without even typing in the calculator. Number 1, we can tell where it crosses the x-axis. Do you remember me saying, I've been saying this since lesson 1.5, that inside lies? Have you heard that statement a few times now? That inside lies? So what I mean is, if you solve this as if this were zeros, if you're looking for zeros, you put 0 equals. What would x actually have to equal if you solve this problem? If you wanted to get rid of the -2, what would you have to do to get rid of the -2? You would add 2. So we have that in the end, x is going to equal +2. So we're going to have a 0 at +2, and we'll also have one. What would x equal over here? -1. And the purpose for this is using an algebra 2 rule. If you're going to multiply, that's what these parentheses mean. If you're going to multiply and get a product of 0, the only way to do so is that one of the 2 factors has to equal 0. And so the way to get 0 in this parenthesis is not to have x being -2. It's going to be x to be +2, because then 2 minus 2 would equal 0. Over here, -1 plus 1 would give us 0. And so that's why we always say inside lies, is because you're solving for x. Now, we also learned about multiplicity. Multiplicity means as if you have powers. You see how this has a power of 3? This one's going to occur 3 times. I'm running out of space, so I'm just going to say mult3, or multiplicity 3. And right here, this one occurs twice. Mult2. So here's what that tells us. If we're going to try to graph this by hand, Here's the x-axis, here's the y-axis. I'm going to leave myself a little bit of space because I'm going to write one more line right here. We know this is going to cross the x-axis at +2 and at -1. That's what we've determined so far. It's going to hit these two spots. And the multiplicity tells me power of 3 looks like an S curve. It's going to go through 2 like an S curve. So it'll either be one of two things. It'll either go through like an S curve there, that way, or it's going to go through like an S curve that way, which we'll determine in a second. And the squared is either going to look like a parabola. It's either going to look like a parabola there, or it's going to look like a parabola this way. We just don't know yet. We'll determine that as we go. So how do we determine that? We have to find a couple things that come naturally in standard form. So here's my next line. If you have a standard form equation, which number 2 is in that form, I'll show you number 2 in a little bit. Standard form finds your leading term. I shouldn't be saying finds, I should be saying gives. Leading term. There's no R there. Let's try that again. Leading term and your y-intercept. Okay, so I'm going to erase the word finds. If you want to leave finds in yours, that's okay. But I think the more appropriate word would be gives. So why do I say gives? It's because looking at the factor form, we were given the zeros and the multiplicity. We didn't have to do any work. They just were showed up for us. The numbers were there. What we don't know is the leading term and y-intercept. That's what standard form gives us. So just so you can see, standard form is when it's in this type of form right here, like number 2. That's standard form when they're all adding and subtracting. Factor form is when you have those parentheses, the multiplication. That's the difference. All right, so back over here. What will this graph look like? Well, here's how you determine your leading term. How you find it if you're not in standard, what you do with factored is this. You multiply anything that has an x together. So you see how I have an x cubed. I'm going to use my parentheses. The -2 does not have an x, so I'm going to ignore that for a second. So I have x cubed times x squared. Which by my count, this is like saying you have 3 x's, x times x times x. This is saying we have 2 x's, x times x. By my count, that's a total of 5 x's. Would you agree with that? X times x times x times x times x is a total of 5. 5 x's is odd, so it's going to look like a S curve. Here's what that tells us. This graph is going to start over here like this, and it's going to end going this way. That's what we just learned. I should have made it curve. It's got to curve towards the y. Curve towards the y, curve towards the y. That wasn't very good. Powers greater than 1, curve towards y. We learned that in lesson 2.1. So it's going to do that. Now remember how I told you this one's squared, which means it's going to be a parabola. We now know it's going to be a parabola going down. And we know this one's going to be an S curve going up. The reason I know that is because of the multiplicity. So you might not have figured all this out yet, but I'm building that so that you know how to do this. So I have a parabola because this one had the squared power. -1 had the squared power, so it's a parabola. This had a cube power, which is an S curve. It's kind of like that little wave right there. Now, if you want to know the y-intercept, you kind of do what we did in the leading term, but this time you multiply with everything that's not an x. So what I would do is that's my leading term right here. That was my leading term. I'm going to abbreviate LT. To find my y-intercept, what you do is you multiply everything that's just a number. So -2 cubed plus 1 squared. Now -2 times -2 times -2. Let's see, -2 times -2 times -2 is -8. And then 1 times 1 is 1. So -8 times 1 is -8. That's the y-intercept. So this thing would drop down wherever -8 is. I'm just going to make it right there. This graph would drop down to -8, and then it would come back up. Whoa, kind of missed my mark there. -8, and then back up. Make it S curve. So that's what it would look like without a calculator. Now let's see how accurate our drawing is here. Do I expect you to be able to do that right now? No. That's why I worked it with you. Let's take a look. The problem was f of x equals x minus 2 to the third power times x plus 1 to the second power. Let's check out the first things. The easiest things we were able to determine where the zeros would be. Positive 2, negative 1. Check out our zeros. Negative 1 and positive 2. Do you see that? The next things, now that we have a good drawing, not my bogus one, you see how at negative 1 it looks like a parabola? That's the multiplicity of 2 up there. The power of 2 made it look like a parabola at that spot. You see how this one makes that S curve I was talking about, that little wave thing right there? That's because I had a multiplicity of 3. Odd powers greater than 1, so power 3, power 5, power 7, anything like that, will make an S curve. And so that's why it looked like an S curve at positive 2. Now that we got from factored form. Remember then for standard form, what we did is we basically said x cubed, let me put the parentheses around it, x cubed times x squared. And what that did is that was our leading term test. And that was able to tell us, okay, from that point, it's going to go down. And from this point, it's going to go up. And so if I zoomed out, you would see this is what we learned about leading term. That was when if you zoomed out, you see how similar these two graphs look? That was leading term. And that's what that found us. And the last thing we did is we found the y-intercept. We took the number negative 2, cubed it, and the number positive 1, and squared that. And we got a value of negative 8. That meant that our y-intercept was negative 8. I'm going to turn off this one so I don't have as much on the graph. So that's how I got that point of negative 8 on our drawing. So our drawing was fairly accurate. But that's how you can do it without a calculator. Not that I expect you to do so, but that's just where we're teaching right now. Is I'm supposed to teach you, if you wanted to do it without a calculator, that's how you would go about doing it. Okay? With that, let's go on to number 2. Number 2 says, describe the end behavior. Oops, sorry. Let me cover up number 3 first, and then I'll read it. Describe the end behavior of the graph, f of x, using limits. Explain your reasoning using the leading term test. Okay, so I'm going to ask the question first here. Which form do we say this is in? Is this standard form or is this factored form? Standard, which means it tells us our leading term. It gives it to you. You remember the leading term is the highest powered term. Which one has the highest power? 6x cubed. So the shape of the graph is going to look like 6x cubed. So to draw it, what you should get used to is if it's an odd power greater than 1, it's going to look like an S. Is this going to be a positive S or a negative S? Meaning, is this positive or negative in its whole entirety? It's positive. So a positive S curve goes like this. It curves towards the y-axis. Because 3 is odd, it goes over the origin. Because 6 is positive, it goes in quadrant 1. Those are all the rules from 2-1. So that's what this graph is going to look like. So when you get to this problem on the lesson exam, all the answer choices are going to have limits. You're going to have a limit that goes to negative infinity for the x, and you're also going to have a limit that goes to positive infinity on the x. And you'll have to discover which of the 4 options have the right value. And so let's look at our picture and we can determine this. The way you would read this is you're basically asking yourself, what happens to y as x goes left? Negative infinity represents x value going left. This one would say, what happens to y as x goes to the right? So left and right, that's what you're asking yourself. As this graph goes left, what does happen to the y's? There's 4 possibilities. It rises and goes up forever. It falls and goes down forever. it gets really flat, or it comes to a point. Which of the four is true? This falls. It goes down forever. What represents falling forever? Negative infinity. That would be the answer for this side of the limit.
I have a question. Okay, so the first got the x is -8, right?
This would be given to you.
Oh.
You actually don't ever fill that in.
Oh.
That's given to you. That just means when you look as the graph goes left, look as the graph goes right. That part's given to you. What you fill in is the y portion.
Oh. Okay.
So now, what happens as we go right? What does happen to the y as we go right? Does it rise? Does it fall? Does it get flat? Or does it arrive at a point?
Right.
It rises. What symbol represents rises? Positive infinity. So that is a lesson exam question. I just want to make sure that's clear because I'm getting so many people not turn in their stuff. I want you to know as we're going through it. That is one of the questions right there. That is a lesson exam question. Give you a few seconds, and I'm going to move on. Is that clear?
Yeah.
Okay. And now let's take a look at number 3. Oh, one more thing. Standard form, I circled this as leading term. What is the least term, if you will? If this is the leading term because it's the highest power, which one has the smallest power on it? Not the -4 because it has an x. I would say the one because it doesn't have a power at all. It has no x. This is your y-intercept. I should have pointed that out. That is your y-intercept. The one that has no x at all is the y-intercept, which means if I wanted to draw this a little bit more accurately, I could say this is going to be shifted up 1 unit. That would be a little bit more accurate of a drawing. It doesn't make a big difference, but it is a small difference. Okay, so I just want to point that out. The 4 pieces of information, let's just write that down in case you want to know it. What's the benefits to the 2 forms? Let's do this like a little quiz here. Here's a great, if you wanted to find, let's say multiplicity. Don't yell out your answers. I'm going to give you a countdown to 5 seconds. Would you want to have, if you were having to find multiplicity, would you hope that I gave you factored form? Or would you hope that the problem was in standard form? Which one tells you the answer without you doing any work? Factored or standard form? 5, 4, 3, 2, 1. Factored. Factored tells you the multiplicity. Okay. What if you were looking for, let's say, the leading term? If you were looking for the leading term, which I'm going to abbreviate, would you want factored form or standard form? 5, 4, 3, 2, 1. Standard form, you're right. Okay, what about y-intercept? Which form? 5, 4, 3, 2, 1. Standard is correct. By process of elimination, you should get this one. What about zeros? 5, 4, 3, 2, 1.
Factored.
Factored form. There you go. So that's kind of the benefits to both. So for each form, you get something given to you, but you have to solve for 2 other things. It doesn't matter which form you're talking about. They each have their benefits and their shortcomings. All right. Now, after this bogus quiz, let's go to number 3. It says determine all real zeros. And I've talked about factored form and I've talked about standard form, but let's just make sure we clarify which of the 2 is number 3. Very good. It's standard form because it's all adding and subtracting. Standard form is adding and subtracting. Factor means multiply. That's when you have the multiplication. So we want to find zeros. What do we have to do? I'll give you a hint. It's in the name. It's in standard form, but we need to change it to factored form. So what do I need to do? Factor. Very good. Good. We need to factor this. Define zeros. So here's what you do. Define a zero. You put instead of x of f of x, you put a 0 there. And as a reminder, we could have a possibility of 5. We will have 5 total zeros. We'll see how many are real, how many are imaginary. We know there will be a total of 5 because it's the biggest power. And we have to factor. The first type of factoring is GCF. Does this have a GCF? Always start there. It's the easiest, and it'll help the whole problem unfold easier. X. Good. Good. I like it. X. So I factor out the X. Now, greatest common factoring is kind of like the opposite of distribution. Distribution, we take something in parentheses and multiply it through. When you do GCF, it's kind of like you're dividing something out, but instead of just removing it entirely, you move it to the front. So if I divide it out with 1x, I'm left with x to the 4th power. And then here, minus 13x to the 2nd power. And then at the end, I would have just 36.
Yeah, how did you get the 4?
Yeah, okay, I divided out 1 power.
Oh,
So I had 5 powers. If I take 1 away, down to 4. I had 3 powers. I take 1 away, down to 2. I had 1 power. I take 1 away. I'm down to no powers of x. So now I GCF'd it, and we do have a factor, but I can actually factor this even more. I see 3 terms. What's the type of factoring we've been doing if you have a trinomial? Meaning 3 terms. X method, perfect. There you go, you're on.
What's your off period, Mr. Voorhees?
4th period today.
Okay, can I come back and see?
Yeah,
I had a
absolutely.
question about Angela Bell, but I'll come back and see.
Okay.
Thank you.
And so if you remember, for X method, you take your A times C, draw an X, and so I'm going to multiply, and then I'll have my B value underneath. -3. Now, if you don't have a good tactic for how to find these 2 numbers, the one I gave you at the beginning of the year is I said, hey, just pretend these are called M and N, and just write out all the chart that can multiply to be 36, like all the possible factors of 36. It's easier to start there. So there's 1 in 36. There's 2 times 18. Just count your numbers up. 3 goes into 36 12 times. 4 can go in 9 times. 5 cannot go into 36, but 6 can. 6 times. And that's my whole list because the 2 numbers have evened out. I can be done. Which one of these, because I have a negative here, I know I got to have at least a negative in this. Which one of these could somehow combine to give me a 13 though?
9 and 4.
Yeah, perfect. 9 and 4. Okay, so now we have to make that be a negative 13. Negative on both sides. -4, -9. Okay, so from here, what you do, this is where some people really mess this up, is you have to take your A term and you split the power. So what I'm left with is, I'm going to have, instead of 1 parenthesis, I'm going to have 2 parentheses, and I split my A power. So instead of it being x to the 4th, if you were to split 4 in half, what does it become? X squared and x squared. So those go in the 2 parentheses. And then the x tells us our side numbers. -4, -9. And now we're ready for our solutions. We got this totally in factor form. So remember, algebra 2 rule, if you're going to multiply and get a product of 0, that means one of the products themselves has to equal 0. It's the only way to multiply and get 0 is that one of these 3 things that are multiplying have to equal 0. Since this one's by itself, we know that one just simply x equals 0. So if this x is 0, 0 times this group is always going to end up being what? 0. So we're good. Check this parenthesis. We would say x squared has to equal 4, because again, inside lies, we need this to be 4, so it's 4 minus 4. Okay, how do you get rid of a square? Square root. Some people forget, when you take a square root that's not originally there, you need plus or minus. Because both +2 and -2, when you square it, gives you 4. For that reason, you need plus or minus. And then one more. Here, x squared has to equal 9. So when I take the square root of that, do the plus or minus, what is the square root of 9? 3. So you have plus or minus 3, meaning a positive 3 or a negative 3 squared still gives us a positive 9. So we have how many answers here? It looks like 3. It's actually a total of 5. I have 0, positive 2, negative 2, positive 3, negative 3. That means I have 5 real answers, and that leaves me with 0 imaginary. I think on lesson exam, I asked you to type them in from least to greatest, I believe is how I asked you. List all answers separated by a comma going from least to greatest. Which one of those is the smallest? And -3. Which one's the next smallest? -2. Which one's the next smallest? The next smallest? 2. And finally, last one? 3. This would be your answer. Don't type it in with spaces. Type it in like that if you want to make sure you get credit. And that's the lesson review.